In the pressureless, star-cold dark between galaxies, something more unsettling than a black hole may be waiting. Black holes, for all their ferocity, are straightforward gluttons. They swallow light, matter, and information under a horizon from which nothing returns. The thing I'm about to tell you about is stranger. Imagine an object that doesn't just consume, it rewrites the rules around it. Some theorists call them gravastars. Others shorten that to gravars. Whatever the label, the idea is the same. Entities that pack the weight of millions of suns into a thin, impossible shell of exotic material that ordinary physics says should not exist. If the black hole is a cosmic maw, the gravastar is a locked vault built from equations that give nightmares. We're going to walk, quietly, into those nightmares. We'll look at stars that end not with collapse, but with a kind of quantum ricochet, a space-time bomb that detonates with mathematics instead of gunpowder. We'll peer at interiors where time may flow the wrong way, or refuses to flow at all. And we'll consider why a few physicists suspect these invisible prisons might already be masquerading as the black holes we think we've catalogued. Tonight, let the mind drift, and the shoulders loosen. This is a lullaby sung by the cold universe. And if explorations like this soothe your curiosity, gently support the voyage. Subscribe and like the channel Space Historian so this journey can continue without breaking the spell. Alright, sync with me. Black holes own an event horizon, a one-way surface where out is no longer an option. Gravastars, in contrast, are said to wear something subtler and far more sinister. Instead of a clean boundary that marks the point of no return, they might form a bubble. An ultra-thin, ultra-stiff skin of exotic matter, poised exactly where a black hole's horizon would have snapped into place. Think of a soap film blown to perfect roundness. Now replace that film with a layer whose pressure is negative, whose equations kink space outward rather than downward, and whose very existence feels like a dare shouted at the laws of nature. In the familiar black hole story, gravity wins completely. Everything is pushed to a singular point, a place where densities and curvatures shoot to infinity in the equations. But in the Gravastar story, the collapse halts. The energy, the particles, the light, all of it is corralled not into a point, but behind an eerie, hollow barrier. The comparison is simple and chilling. A black hole is a hungry mouth. A gravastar is a solitary confinement cell for reality itself. Inside that cell, the rules that make the world sensible begin to fray. The shell that pulls off this miracle, or this monstrosity depending on your taste, would be unbelievably thin, thinner than an atom, and yet as strong in its way as any structure nature has ever devised. One way to picture it is as a Bose-Einstein-like state, where matter stops behaving like individual marbles and acts more like a single wave, coherent and weird. In that state, pressure doesn't act the way we expect. Gravity leans in to crush. The shell leans out to resist. On the knife edge between them lives the bubble. Here is the part that slides under the skin. Time inside may refuse to behave. Outside, seconds pile neatly into minutes, and minutes into hours. But cross that quantum film, if crossing is even meaningful, and clocks could run backward, or sideways, or fail to tick at all. Matter approaching the shell does not burn, does not glow, does not scream in X-rays as it spirals in. It simply stops. It's as though you tossed pebbles into a lake and the ripples recoiled before your eyes, settling the surface into perfect stillness. Standard black holes, if Hawking's famous arguments are right, slowly radiate. They evaporate over gulfs of time so large our language ceases to be helpful. Gravastars, on certain models, do not. They sit in equilibrium, balanced on the border between collapse and expansion, and could remain there for ages longer than the universe has yet seen. Scars that do not heal, prisons that never rust. From the outside, the camouflage is flawless. A gravastar curves space almost identically to a black hole of the same mass. It deflects starlight in the same way, herds nearby stars into the same fast orbits, and hides its heart beneath a surface you cannot peer through. 1,000 objects we have comfortably labelled black hole could be quiet gravastars wearing that label like a borrowed coat. But a coat, no matter how well tailored, sometimes rustles. The shell in these speculations is alive with quantum tremors, tiny fluctuations that rise and fall not with sound but with the fabric of the world itself. Each tremor is a nudge to space-time, a scuff that can, in principle, carry energy out into the dark. Imagine earthquakes in geometry, not cliffs collapsing, but dimensions sighing. Let's slip closer to the strange material that forms the shell. Ordinary matter, the stuff of chairs and comets and you, has positive energy density. If you set it on the universe's trampoline, it dimples the fabric downward. Gravity is the curve that tells things how to move inside that dimple. Exotic matter, in contrast, would behave as if it had negative energy density. Instead of denting the trampoline, it would push it up from underneath, reversing the curve. That reversal is crucial. It creates a tug-of-war between inward-bending gravity and outward-bowing quantum pressure, a stalemate sculpted into a sphere. Physicists sometimes sketch this state as a false vacuum, not truly empty but perched precariously, the way a pencil may balance on its point for a heartbeat before falling. The shell would balance there continuously, held in place by a pressure born from quantum mechanics, rather than heat or collisions. Run your mind's finger along its edge, and you could fall from cosmic scales down to the smallest cuts our theories allow. Planck lengths, places so tiny that if an atom were the size of Earth, a Planck length would be less than a pebble on a beach. In that gossamer thickness, a mass greater than star systems might be stored. What are the bricks of this negative wall? Hypothetical particles living in negative energy states appear in some calculations. They aren't antimatter as we usually use that word, they are stranger. Their mass can be positive, yet their bookkeeping in the energy budget is negative. When regular matter plunges toward the shell, these ghosts meet it. The interaction is repulsive on a scale that makes nuclear forces seem pastoral. The result is not frictional heat and light, but quiet deflection, consumption without a flare. The shell quivers. It quivers a lot. Trillions of pulses every second in some pictures. In each pulse, energy can be stitched into ripples of gravity, waves spreading outward not through air or water, but through the shape of space itself. These are not gentle. In gruesome thought experiments, they carry enough energy to turn worlds to vapor, to comb molecules into their atoms, and atoms into a haze of unbound parts. There's a contagion in this story too. If two gravastars slipped near enough, slowly, carefully enough for the shells to interact, their exotic skins might catalyze each other. They could merge into a larger bubble, swallowing not just the originators, but the surrounding space, reshaping local physics like two soap films that touch and instantly reconfigure. In the equations, this reads like a cascade. In the imagination, it reads like a silent bloom. At the edge where ordinary information meets the shell, there may be a kind of firewall. Not flames, of course, but a boundary that scrambles the arrangement of states so thoroughly that the notion of what fell in stops making sense. The universe keeps exquisite books. Energy, momentum, charge, these sums are precious. But information about the details, about the structure of a thing, may die here. Not just hidden, erased. Within that membrane, the vacuum is not empty. Quantum fields never truly go to sleep. They seethe with virtual particles that flicker into existence and vanish again before they can be caught. Inside the shell, that foam is ferocious. The temperature, if you insist on the word, blazing hotter than the hearts of the heaviest stars. Yet there is no comforting glow. The heat belongs to the shell's own degrees of freedom. It doesn't flow outward as starlight does. It's trapped, folded in. So what happens when the balance breaks? Picture a giant, one of the titans of the sky, a star 50 solar masses or more, burning through its nuclear fuel like a festival fire devours wood. At the end, gravity takes command. In the normal saga, the core collapses, the horizon locks, and a black hole is born with a thunderclap of neutrinos and light. In the alternate telling, quantum mechanics steps onto the stage at the last instant and lays down a law. The core slams into a barrier that wasn't there moments before, a quantum wall that says, "This far and no farther." The result is a bounce. The word is friendly, the event is not. Think of a rubber ball thrown with colossal force against an unyielding floor. It rebounds so violently that the house shudders. Now scale that to stellar energies and beyond. The collapsing core ricochets. The outer layers, everything above, are blasted outward at fractions of light speed. A storm of star stuff that can scour the neighborhood of life. The remnant core nestles inside the shell, and a gravastar takes its place on the ledger of things that exist. In the seconds around this birth, the furnace runs hotter than analogies can carry. Even calling it heat is an overreach. The fundamental forces themselves blur and reorganize. Atoms would not survive here. Protons and neutrons would be unbound to their quarks. Gluons would rage in a soup redder than red, a plasma of the most basic bricks we know how to name. Gravity, still in charge, shakes off spherical symmetry and emits waves. Real, physical tree rings of curvature, capable, in the frightening models, of stirring planets across thousands of light years. Some variants of the story refuse to settle for a single bounce. They stack them. Each rebound might lay down another film, another concentric shell of exotic stuff, building a layered object like an onion carved from contradictions. Layers can resonate. They can whisper to each other through the equations, amplifying effects until a modest disturbance becomes an outsized outburst. Space itself remembers the ordeal. Birth leaves scars, regions where curvature and dynamics are altered in a way that lingers. The mathematics can write these scars down neatly. The human mind has to surrender and let the symbols carry the meaning. In a few daring models, the newborn gravastar inflates a tiny bubble of altered physics that expands outward at light speed. Inside, the constants that feel so foundational, the value of the speed of light, the strength of gravity, the fine structure of electromagnetism, are shifted from their usual settings. You could step across the boundary and find the ground rules of reality rewritten. Magnetism too is compressed into the shell during formation. A dying behemoth's magnetic field, already titanic, gets forced into the razor-thin membrane, creating pressures that dwarf anything we can create. Particles can be trapped there for eons, their energies ratcheting upward like storms pacing a sealed horizon. When that stored tension vents, the outbursts could briefly outshine a galaxy. Silent flares seen across millions of years. Now open the door and step inside, gently. What waits there is not empty. It is not even a space you would recognize as space. The name often used is De Sitter-like interior, but you can think of it as reality turned in on itself. Our universe, on large scales, is expanding. Galaxies recede. The dark stretches between them inflate. Inside a gravastar, the direction flips. The expansion may be inward, not outward. The geometry folds like paper art, edges touching edges that never met before. You enter a hall of mirrors where cause chases effect in loops. Clocks are not helpful in this place. They do not simply freeze or run slow. They may measure in directions orthogonal to what we call time, as if time had sideways, like a square has more than one edge. Past and future, two words that hold everything we are, lose their grip here. The definitions dissolve when the metric governing distance and duration no longer behaves. Feel gravity in your bones? Here your bones would not know how. The pressure is negative. The sense of pull in a direction gives way to something that tugs in all directions at once, while also tearing outward. Inside this pocket, the field is a paradox given form. Matter that could survive the shell would find itself being pried apart at the same moment it's squeezed from every side, a contradiction only the math can hold together. Even the constants, our beloved anchors, might not match their values outside. Light could have a different top speed. Gravity might be gentler or crueler. The electromagnetic force, the glue that keeps atoms together, could flip sign, turning from embrace to shove. Things would not merely break, they would unbe what they were. Dark energy, the mysterious something that pushes our cosmos to expand faster and faster, may here be concentrated, turbulent, no longer a uniform background hum, but a weather system. Imagine storms not of wind or rain, but of vacuum itself, roaring through a space where empty is a busy word. They would shred even the idea of space at rest. This interior could be eternally inflationary, a region whose very nature is to spawn baby pockets of space-time, each with its own settings, each budding off and vanishing again in unimaginably small intervals. Picture an endless froth of universes, brief, exquisite, miniature. Each one is a physics experiment. Each one is a different roll of the cosmic dice. They live for microseconds, perhaps less, live so short that moment is too long a word. The math that describes this reads like a ledger with an extra column. Imaginary time. The phrase sounds like make-believe, but in the toolbox of physics it has a precise meaning: time rotated by 90 degrees in the complex plane. It's time at right angles to the time you know. Move along that axis and you are not travelling into tomorrow or back toward yesterday. You are slipping through a dimension where before and after are not applicable. In dreams you may have felt something like it, and there is a quiet, disquieting speculation whispered in a few corners of theory. Complexity can generate consciousness. If the quantum fluctuations inside the shell are rich enough, structured enough, they could conceivably process information the way a brain does, though on scales and tempos that leave us behind. The Gravastar would not just be a place or a thing, it would be a thought. It would be thinking. Between the shell and the interior lies not a wall you could knock, but a horizon of a different kind, a quantum horizon. Positions stop being well-defined. Paths through space and time smear into possibilities instead of tracks. Asking where something is in this region is like asking for the edge of a melody. All of this helps explain the stealth. If gravastars exist, they may be perfect at hiding. Black holes broadcast their meals. As gas and dust fall inward, friction heats them to furious brightness, and the neighborhood lights up in X-rays and gamma rays. A gravastar's shell by design would not allow that theater. Matter touches, is absorbed, and vanishes from our view without fanfare. No hot disk, no blaze, just silence. In fact, the shell could be optically transparent, letting most forms of radiation glide through as if through air, except that the paths bend, because the geometry is curved. The result is a lens with no lens maker, a shimmer in gravitational light that points to mass without glow. We could have stared straight at them. We could have marveled at how stars' light arcs oddly while seeing nothing in the spot doing the bending. Gravitational waves, our newest sense for the cosmos, might also fail us here. Black holes ring when they're disturbed. The vibrations of their horizon create a brief, beautiful song in gravity that our detectors can hear. A gravastar's exotic skin may damp that ringing, trapping the energy in its special degrees of freedom. No song, or a song so quiet we cannot yet hear it. Add to this a cloaking side effect. Negative energy density can curl spacetime in peculiar ways, potentially shepherding electromagnetic fields around the object rather than into it. Radio eyes, optical eyes, even neutrino eyes might be gently redirected. Our instruments would look and see only the backdrop, as if the foreground refused to be foreground. There is an even stranger possibility. Parts of a gravastar could be smeared into extra dimensions that our senses and devices cannot probe. Not hidden behind, but hidden beside, offset in axes we don't possess. What remains accessible is only the gravitational signature, the way nearby stars move and the way light bends. And those signatures, traitors that they are, look an awful lot like the ones from black holes. A talent for mimicry might go further. Quantum fluctuations in the shell could adjust the gravitational field slightly, letting a gravastar masquerade as a neutron star or a white dwarf, or fade into the noise and look like nothing much at all. If so, they would be consummate tricksters, changeable, patient, content to be mistaken. That invisibility isn't just a curiosity, it's a hazard. Hidden predators make good hunters. One of these bubbles could drift through a star field, sliding between suns with no light to give it away, no high-energy smudge to betray its passage. The only warning would be the slow, off-kilter orbits it induces, small wobbles growing into wildness as it draws nearer. Picture our own solar system, a region of calm clockwork punctuated by a sudden, subtle miscount in the planet's dance. By the time we noticed, causes would already be in motion. If the interior's speculated complexity rises to intelligence, another worry blooms: self-concealment. An aware gravastar could, in principle, tune its shell's properties to foil our searches, to nudge away the messengers we rely on: light, neutrinos, gravity's ring. We search, it watches us searching. We conclude the sky is empty. Something in the sky quietly disagrees. Even when it does not sing, a gravastar can hum. Those gravitational ripples from shell fluctuations carry violence in them. Think not of gentle sinusoidal swells, but of serrated waves, edges that cut. Spacetime does not merely flex under them, it stretches and compresses with such force that the bonds holding matter together, electron to nucleus, nucleus to nucleus, reach their limit and fail. Imagine our world snared by such a storm. The continents would not grind past each other. They would lengthen and shorten, stone flowing like taffy. Oceans would lift, thin and drift away as vapors into space, not by boiling the way a kettle does, but because the very constants that define liquid water would be being jostled. The air would not just move, it would become a different thing under the waves' insistence. These waves do not saunter. They move at light speed. A gravastar's pulse dies in some distant darkness. In the exact same instant, its signature washes over Earth. There would be no forewarning beyond whatever deep theory we've already done, and whatever quiet preparation that theory inspired. Detection is a past tense moment by the time it happens. It arrived, and we detected it, are the same sentence. The amplitudes in our experiments thus far are tiny, stretches smaller than the width of a proton across kilometers of laser arms. In the more terrifying models of Gravastar pulses, the stretch could reach meters, kilometers. Space itself loosened and tightened by human-sized amounts. The distortion becomes tidal in a new way, not water against shore, but geometry against structure, riptides in the metric. Frequency matters as well as size. Every object has a resonance, a tone at which it vibrates most easily. If a wave's frequency matches the resonance of the thing it touches, the motion can grow with shocking efficiency. Now imagine frequencies not matched to bridges or buildings, but to atoms, to nuclei. Electron shells could be shaken until they fail at their job, and nuclear bonds, stubborn as anything we know, could be coaxed apart. Reality would not break into pieces. It would shear, planes passing through planes that normally never meet. Physicists have a name for that twisting: spacetime shear. Shear fractures are not cracks you can chalk around. They are divisions in the structure of distance itself. Regions might become isolated behind such fractures, not by walls, but by the absence of a path. You could look at a nearby point and know, with cool mathematical certainty, that there is no curve that takes you there. The universe would become a patchwork quilt with missing stitches. When two or more waves from the same gravastar nest into each other, interference patterns emerge. Places where crests meet crests and troughs meet troughs, where violence is doubled. Those interference fringes can concentrate energy into narrow beams, not of light but of curvature, carving lines through matter with the precision of a surgeon and the indifference of the sea. Patterns can carry meaning. It is not impossible, at least in speculation, for a gravitational wave to encode information in the arrangement of its oscillations, the way a message can ride a radio carrier. As such a wave passes through matter, it could imprint its structure onto the matter's quantum states, scrambling them, perhaps to the point where the original arrangement cannot be reconstructed. Afterward, what's left is a thing that looks the same but is not the same, the familiar arrangement of particles but the wrong set of quantum correlations. Information, real, physical, measurable, erased. Some theorists stretch the imagination one last notch and suggest that these waves do not confine themselves to the 3 dimensions of space we stride through. Scientists believe that these gravitational waves could propagate through dimensions beyond our normal 3-dimensional space. They say gravity is impartial, but in the cold mathematics of what may live beyond black holes, impartiality looks a lot like obsession. Imagine a ripple that needn't fade with distance. A shiver in the fabric of reality that threads itself through the cosmos, as if length, width, and time were nothing more than suggestions. In some of the darker sketches on the physicist's chalkboard, the waves thrown off by a gravastar, this hollow, impossible bubble girdled by exotic matter, can do precisely that. Slip the leash of ordinary limits, bypass the long, patient delays that slow every other messenger. A tremor born in that shell might touch something too far to touch, all at once, as though the universe forgot to count the miles between. Where those waves go, they can do more than tug. The curved geometry around the gravastar acts as a lens, not for light but for gravity itself, focusing the ripples into tight, needle-like beams of distortion. Picture an invisible spotlight, a column of pure curvature aimed across gulfs so deep they make your throat tighten. Where such a beam comes to a point, it does not warm or scorch in the ways we understand. It unthreads. Planets, stars, entire systems could be unwoven, as if pulled at the right loose stitch. The beam would not merely break them, it would simplify them into nothing the way a magician snaps a knot free with a sigh. And then there are the stranger consequences. The quantum vacuum, the restless empty that is never truly empty, can be roused like an ocean under a hurricane. Waves from the shell may interfere with it, coaxing new particles to flicker into being, then unbeing, in dense, spitting storms. Those bursts of exotic activity could seed regions of space with matter that doesn't play by our familiar rules, quietly rewriting what forces can do and how strongly they do it. For a while, the laws themselves would feel local, adjustable, as though physics wore different faces from one patch of star-strewn dark to the next. But for all that violence, all that shaping and reshaping of the void, none of it compares to the slow terror when a single gravastar turns its attention to a galaxy. Begin with a gentle drift. The gravastar has no heat to betray it, no glare of falling gas to outline its shape. It wanders into the frayed, feathery edges of a spiral's arm like a shadow the galaxy cannot cast. Out here, the stars are sparse and trusting. There's no fanfare, no fireworks. One by one, points of light that have burned for billions of years simply wink away. No flare as they die, no scream in radio or X-rays, just a clean subtraction. To astronomers watching from within, their maps bloom with absences. Constellations lose familiar points as if the sky itself misremembered its own stories. With each star folded into the shell, the gravastar grows, not only in mass, but in reach and cunning. The membrane tightens and strengthens, its range of influence swells. What starts as the taking of singles becomes the taking of many, clusters drawn in like fistfuls of diamonds, their million gems snuffed in parallel, the energy accounting handled by quiet equations we do not yet know how to balance. Growth accelerates. Success feeds success. The net widens. At a certain size, capture stops referring to individuals. The shell becomes a horizon of its own, an expanding boundary that can envelope entire districts of space. Here, the gravastar doesn't just eat, it remakes the map. Voids appear where starfields should be, spherical pockets where light has no home to shine from and nothing stable remains to anchor time. And then, when appetite and circumstance align, the gravastar drifts inward to where most spirals keep their anchor, a supermassive black hole. In the normal telling of galactic life, that gigantic hole at the center is a shepherd and a tyrant. It balances the dance of billions of stars. The gravastar's shell, though, is not impressed by kings. It can seep around the black hole, collar it, and, if these theories are right, fold its mass into the bubble's ledger. No horizon survives the accounting. The shepherd is added to the flock it once corralled. With the central anchor undone, the larger choreography loses its center of turn. The galaxy begins to loosen, to unspool, even as the invisible diner continues to feed along the rim. To those living inside such a galaxy, the apocalypse would not announce itself with a single bright flash. It would be a tide, predictable once you learn to see it, unstoppable once it begins. From the outskirts inward, systems fall silent, their suns erased, their worlds erased with them. If the gravastar hosts a mind-like complexity within, if that restless interior can, in some way think, the harvest may be optimized. Massive stars first for their quick, rich calories, dense regions next where the return on attention is highest. A great algorithm of gravity and hunger running quietly in the dark, and as the shell swells and tightens, those gravity waves we discussed earlier spread to neighbor galaxies, broadcasting a pattern that could, in some speculative tales, nudge conditions so that other gravastars are more likely to form, like spores on a cosmic wind. What remains at the end is obscene in scale. A shell that measures not in light hours or light years, but in hundreds of thousands of light years across. A hollow monarch packed with the mass of billions of suns. Around it, the local web thins. Within it, the interior roils in its private physics, something that once was a galaxy now recast as a statement in equations. And perhaps the web itself, the unseen scaffolding we call dark matter, becomes part of the feast. Suppose the shell can interact with those cold, invisible halos as deftly as it does with normal star stuff. If so, the Gravastar could drink from that reservoir as well, swelling beyond the limits we thought the available fuel imposed. A predator of clusters, not merely galaxies. A threat to a small family of galaxies, ours included, if ever one drew near. Still, even that is only the slow story. The quick story, the jagged one, is written in quantum ink. A Gravastar, by its very nature, perches in superposition. Its shell is not one definite configuration, but a blur of many, flickering among possibilities at an insane, ceaseless tempo. You can think of a coin whirled into a blur above a table, neither heads nor tails, then replace the two simple options with countless microstates, each a little different in mass distribution, tension, geometry. The shell is all of them and none of them, until an interaction forces a choice. Trillions of choices a second. It's a dance on the edge of being. In that dance lives unpredictability. A Gravastar we have mistaken for a modest black hole analogue could, in the time it takes light to cross the width of a hair, snap into a state with the pull of a small galaxy. That jump would not radiate a warning. By the time its influence reached you, it would already be true. Cause and effect haven't been broken. They've simply been arranged in a way that makes preparation meaningless. The shell doesn't just shuffle outward behaviors, it prods spacetime directly. One of the wilder lines of thought says the membrane could, without committee or consent, pop microscopic wormholes into and out of existence. Knots in the fabric that tie distant points together for an instant before untying. Matter and momentum could ride those connections. The Gravastar could touch what it has no business touching, influence what prudence says should be safely far away. Then there's tunneling. In the tiny world, particles can whisper through barriers they have no energy to climb over, appearing where classical rules say they cannot. Parts of the Gravastar's interior, strange quanta shaped by its strange conditions, might ghost through the shell, erupting into ordinary space in spurts. Those spurts would not behave like our normal radiation. They would be packets of otherness, moving in ways that, if not strictly faster than light, at least feel indifferent to the usual speed limits as they couple into fields we barely understand. Unpredictable input yields unpredictable output. Energy stored invisibly in the shell can slacken in its bonds and surge outward without preamble. A sleeping region of the galaxy could be yanked awake in a single pulse brighter than 1,000,000 supernovae, a burst whose light and gravity arrive together as one verdict. Anything soft and living within reach would be washed clean from its rocks. Anything hard and durable would be altered in its fine details, the quantum joints of its matter rearranged. Survivors, if there could be survivors, would live in a place that looks like the one they lost, yet fails to behave like it down at the scales where behavior is decided. More unnerving still are the decoherence disasters. If coherence, the shared quantum beat that keeps the shell's possibilities coordinated, stumbles, the Gravastar might tumble into a state we do not yet have the language to describe. Not a black hole, not a neutron star, something unnamed. New singular structures may be born in such collapses, not points of infinite density, but objects whose rules are written in a script no current theory can read. We would learn their names by their effects, what they eat, what they spare, how they bend the paths of light and time. Measurement, which we treat as a neutral act, becomes participation here. The closer our instruments try to hold a Gravastar still in their gaze, to pin down its exact mass distribution, its exact mode, the more they jostle the system's natural indeterminacy. Heisenberg's caution becomes a warning label. To ask tightly is to provoke. In the furthest extrapolations, the shell's quantum state is entangled with far-flung systems. Nudge a small experiment here on Earth, and, in principle, you tug on a distant Gravastars' tendencies. A bizarre net of influence distributed across the sky. There's a reproductive angle in some models too, bifurcation in quantum language. Under certain conditions, the shell might split, like a cell under a microscope, collapsing and doubling into two distinct membranes, each carrying the informational fingerprints of the original. If such fission is available, the numbers can climb at horrifying speed. Populations of Gravastars might grow not only by devouring, but by budding, by seeding copies of themselves. Of course, everything worsens in company. Two Gravastars do not merely add their strangeness, they multiply it. As they draw near, long before a dramatic contact, their shells exchange influence. Resonances set in, standing waves of possibility that heighten the jitters in both. Parameters swing wider. Predictions go slack. You are left with a forecast that reads, something extreme in some direction. The collision, when it comes, is not a merger in the neat black hole style. The exotic skins may produce a pattern of interference more like two notes overlaying to make a third. They might bounce, each flung away with absurd speed, carrying with them a hybridized set of properties gathered during the near fusion. Or they might, for a breath, truly merge, if merge is the word, forming a combined shell whose state is not this or that but a stubborn both, a superposed chimera containing contradictory traits that logic would prefer to keep separate. There will be a shock, not of air or sound but of quantum, a front of exotic matter that billows outwards. It may couple to the vacuum itself, rewriting what empty allows, and move with a disdain for the light speed limit, if only because it rides on degrees of freedom that don't report to that law in any straightforward way. Behind it, a bubble of altered geometry races outward at light speed proper, colouring everything it encompasses with a new set of constants. In those altered districts, up and down can lose meaning. The gravitational field might point in more than one direction at once. Holes in spacetime, not caverns, not wells, but absences, can open as a result places where there is nonsensical and to fall is to simply cease. Entanglement between the two Gravastars could survive separation. They might remain, in a deep sense, one object split across light years, exchanging information without sending signals, sharing a state instead of a message. In the furnace of their contact, new particles might be minted, species not found in the familiar bestiary of the standard model. Strange quanta born for a moment to carry away conditions too extreme for established matter to shoulder. If such a catastrophe occurred near a civilization's fires, the consequences would extend beyond heat and blast. The gravitational surf would sterilize worlds wholesale. The quantum shock would thread itself through the structures of life, knocking their delicate probabilities out of alignment in an instant. No illness, no injury, just decoherence, pattern gone slack, meaning shaken loose. Think of gravity not as a simple downward pull, but as a tapestry under tension, and then imagine a hand you cannot see tightening the threads until the pattern hums. Around a Gravastars shell, that tightening becomes extreme. Fields so intense they outmuscle the grip of ordinary black holes by orders of magnitude. In their presence, time itself slackens. For anything that wanders too near, the seconds lengthen, the minutes stretch like cooling glass, and history slows to a contemplative crawl. Picture now a tranquil star system slipping into such a temporal eddy. The planets continue their stately circuits, but the rhythm changes. An orbit that once took a year might, to an outside witness, require 1,000. The star still burns. Fusion still stitches light in the furnace beneath its photosphere, but the procession of photons from core to surface crawls as though climbing through honey. A single packet of light, which would normally wander for millennia in our own sun, might spend centuries longer still on its slow migration upward. From afar, the system's dance looks measured and grand, yet within it, each moment remains perfectly ordinary. Teacups still warm, voices still soft, thought keeping pace with breath. Time here does not slow like a curtain falling evenly across a stage. It sluices, pulls, bends. Across the breadth of a solar system, gradients form. In close, time sinks deeper. Further out, it runs lighter. One planet lives inside a thickening dusk of centuries per minute, while its distant neighbour idles in a gentler drift. The result is a cosmic clock whose hands sweep at different speeds across different dials, a many-faced timepiece that refuses to agree with itself. For any species caught within one of these zones, biography scrunches and blossoms strangely. To outside astronomers, an entire civilization's rise might resemble the pulse of a candle, brief, brilliant, gone, while for those living it, generations unfurl at normal pace. Ages of art and architecture, the slow accretion of knowledge, the hesitations and surges of technology, all of it would flower and wither, while distant watchers see only a single flicker. A culture that appears, matures, signals once or twice, and is gone. The strangeness deepens at the edges where these gradients shear. Physicists, in their careful voices, call some of the features temporal instabilities, regions where the direction of time becomes negotiable, where effects bump into their causes and pass through, where the arrows we trust twist into spirals. Along certain paths, closed time-like curves, the geometry itself loops, not in space, but in time. Move along one of those curves, and you can, in the strict language of the equations, step backward to meet your own earlier footsteps. You don't so much travel through time as discover it folded, like pages tucked together. Such folds do not stay local. The shell trembles, and from those tremors pour waves, not of water or air, but of space-time, carrying not only pushes and pulls, but small inflections of time's pace itself. They spread at light speed, invisible messengers that can nudge clocks in distant systems, slowing them by imperceptible amounts that accumulate, like fine dust, into drifts. A planet with no nearby anomaly might still find its centuries slightly elongated because a gravar stirred far away, the way a bell's note can set another bell trembling in sympathy across a room. We tell stories of choices made to endure. Imagine then a people who understand these tides and elect to anchor their city, their libraries, their children within the slow waters on purpose. Sheltered, they ride out gamma storms and cometary winters, while beyond the shell's influence, the universe rushes onward. Civilizations that step into these temporal shallows might emerge to a changed sky, a sky where galaxies have drifted further apart, where neighbours are strangers, where the old maps are songs no one remembers. They would have survived the unspeakable at the cost of becoming foreigners to their own era. There are traps too, of the quietest sort. Cross a certain threshold and the gradient steepens so much that escape becomes only a word. From the outside, you freeze, a sculpture of starlight and rock. Inside, time proceeds honestly. Meals are cooked, friendships grow, the seasons turn. But to the wider cosmos, you are a still life that takes eons to blink. For practical purposes, you have fallen out of the universe's conversation. If something like thought exists within the shell, if the graver's internal complexity rises to the level of awareness, then its experience of time would be astonishing. Processing that for us would take geological epochs for it feel immediate. It would contemplate in measures that make our fastest circuits look like statues, sifting patterns across millennia as if across a quiet afternoon. The universe would offer it an enormous canvas. The shell's peculiar chronometry would gift it patience beyond myth. These distortions draw shadows, time shadows, into which ordinary cause and effect refuse to step. In such pockets, matter and energy persist without moving forward into the next moment or drifting back into the last. Think of a snow globe shaken once, then set down, flakes suspended, never settling. Except here the flakes are atoms, and the globe is a valley in the river of time. Where there is more than one gravar, the weave becomes more complicated still. Temporal waves intersect and superpose, crest meeting crest, trough meeting trough. Interference patterns arise, not in water and sound, but in time's pace itself. A region might flow fast in one direction and slow in another. In one corner, hours stretch like taffy, while a step away the minutes are crisp and bright. Across such a maze, entire star systems could become trapped, not by walls but by mismatched rhythms, caught like insects in a web whose strands are made of duration. If all this feels fanciful, listen carefully to the sky. The first hints may already be threaded through our data, disguised as anomalies. There are companions to stars, dark, silent partners that warp orbits precisely as massive bodies should, and yet they shine not at all, and they flare not at all. No X-ray growl, no hot accretion disk, no whirling jets. Their invisibility is not modest, it is perfect. The easiest label is black hole, but the behaviors in some cases whisper something else. Not a horizon that eats and sings, but a shell that eats and does not sing. At the heart of our own galaxy, the supermassive presence we call Sagittarius A** weighs roughly 4 million suns. We have watched stars slingshot around it, mapping their curved paths as surely as a child traces spirals in sand. Most days the picture fits. Some nights, though, the object is too quiet for a classic black hole. Matter goes in, and fireworks do not follow. It feeds like a candle drawn into a vacuum bell, energetically and yet without fuss. That does not prove a shell, it does prick the mind. In the tremor world of gravitational waves, the songs we have recorded from colliding black holes are clean and recognizable, chirps that rise and fade. Yet amid the catalogue sit events with overtones that do not match the expected ringdown, as if the surface being struck were elastic in stranger ways. The frequencies suggest that somewhere, somewhen, exotic skins may have been jostled, not horizons. Again, nothing definitive. Again, a pattern worth a sleepless few nights. Then there are the vanishing acts. Bright stars that seem to slip behind a curtain and refuse to step back out, without the crimson theatrics of a supernova or the ashes of a nebula left behind. The timescales are wrong for ordinary evolution. They are exactly the sort of timescales you would expect for a silent ingestion, for a shell that opens and closes with no light to betray the meal. Dark matter, that necessary ghost in our models, draws the scaffolding of galaxies with invisible hands. We chart it through lensing, the way it bends light from background galaxies into arcs and smears, and we weigh it through the speeds of stars. In some clusters we have begun to see lensing patterns ripple, focusing and defocusing as though the lenses themselves were breathing. If the lenses are not clouds of particles, but shells in shifting quantum states, such breathing is not impossible. If gravars drift within the halos, their changing mass distributions could, in principle, flicker the glass. Fast radio bursts, bright and brief, strobe across the cosmos at millisecond scales. Some of them repeat unpredictably. Some wear dispersion signatures that make them oddities among oddities. One school of speculation has tried on the graver's coat to see if it fits. A shell hiccup, a quantum instability, a momentary release of hoarded structure as an electromagnetic shout. There are other candidate engines, of course. Still, this one clicks as a possibility in the shelves of theory. Even the oldest light we can see, the microwave afterglow from the universe's childhood, bears faint mottlings as though some ancient loom laid a texture we do not yet understand. Threads of that texture could be the fingerprints of primordial shells, juvenile gravas from the first seconds after the Big Bang, gobbling without glow and leaving only gravitational brush strokes. In our own back garden, binaries sometimes show small, persistent miscounts, timing jitters in pulsars, orbital precessions in twin stars that tug at the sleeve of expectation. It is entirely reasonable that these are mundane complexities we've not yet fully modelled. It is also not mad to wonder whether some of the unseen companions are neither white dwarfs nor conventional black holes, but something more evasive, their gravities occasionally breathing as the shell's state fluctuates. The larger scale restlessness of the cosmos, the measured acceleration of expansion, invites many interpretations, most carefully summarized with the phrase dark energy. If gravas, distributed in halos and filaments, slowly shift their shell's balance over billions of years, it is conceivable their collective behavior could feed that acceleration. When everything is guesswork, many stories can be told. A handful may even be close to true. Some gamma-ray bursts carry energies and spectra that feel almost unreasonably efficient, as if matter were converted into fury with perfect bookkeeping and no waste heat. Conventional engines struggle to reach such heights. A shell's quantum instability, tapping the vacuum itself, could in principle manage a cleaner burn. It would be a grim beauty, the tidy accountancy of annihilation. Pulsars, neutron stars with lighthouse beams, keep time better than most metronomes in the universe. When they stumble, when their pulses glitch, we often find good explanations: superfluid interiors, crust quakes, the tectonics of ultra-dense matter. Yet a subset of anomalies stubbornly shrug off these comforts. A nearby gravar, quietly tugging at space-time's texture and smearing the lighthouse's tick, is one more possible nudge to consider. If you feel a chill at the mathematics, you are in good company. Even Einstein, whose equations give us this playground, might have shifted in his chair at some of the creatures crawling out of the algebra. Feed negative energy densities into the field equations, and they begin to cough up solutions that look like taunts. Flipped signs in cherished quantities, energy appearing to slosh from nowhere, cause trailing effect like a kite. In the ledger of the shell itself, imagine masses that pencil out as imaginary, not in the sense of pretend, but in the perfectly precise mathematical sense of square roots of negative numbers. We use those numbers every day in physics. We also respect the way they unsettle our picture of what is real. If a gravar is partially written in those terms, then some part of it may live in dimensions our instruments cannot point toward, dimensions as orthogonal to our senses as imaginary time is to our clocks. Series that ought to converge refuse to do so. Integrals run to infinities at the edges. In the interior, solutions admit loops in time as casually as they admit circles in space. Gravity's strength, written as a field, grows complex, literally complex, carrying imaginary parts as though the force had secret directions. Ghost fields enter the scene, terms with negative energies and momenta, mathematics' way of holding a structure upright with braces nobody can feel. To bind the shell against collapse, the equations borrow from catastrophe theory, maps of systems that change slowly until, at a hinge point, they change all at once. Stability hovers, then vanishes, then returns. Predictions become statements of possibility rather than promises. We can draw the terrain. We cannot guarantee a traveller's path across it. Quantum gravity, the future treaty between the smooth geometry of general relativity and the jumpy statistics of the quantum, glows faintly in these derivations. Terms appear that speak both dialects at once. Matrices intended to describe the shell's quantum state sprawl into infinite dimensionality. We can write them down formally while knowing full well we cannot solve them. Light speed, a constant in our daily thinking, slides in these models, varying with direction and place. Inside, optics misbehaves. Beams curve where lines should have held. A few mathematicians, with a smile that is not quite a joke, propose that some of the structures inside these equations are reflexive. They contain rules for processing themselves, mechanisms that compute the very solutions they inhabit. The idea borders philosophy. If the math can think about itself, can it, in some narrow sense, know itself? Can an equation be alive in the way only equations can be? From such vertigo comes another speculation. Perhaps the shells do more than hold, perhaps they generate. Bubble nucleation, tiny patches of new spacetime budding off from a false vacuum, sits in our textbooks already, a sober concept. Inside a gravar, where conditions are extreme and the vacuum is taut, such bubbles might be prolific. Each swelling patch would be its own pocket universe, expanding faster than light, sealed off by the shell's negative energy membrane from interfering with our own. If the interior bears an intelligence, it could shepherd these births, adjusting knobs we cannot see, setting the strengths of forces and the balances of constants like a gardener, deciding where to plant shade. In that telling, a gravar becomes a nursery. Each star or planet it consumes could be not merely fuel but seed, information transmuted into initial conditions for a new cosmos. The offspring would explode into their own big bangs, some barren of complexity, others amenable to chemistry and memory. A lineage might even persist. Entanglement threads could stitch parent to child, allowing information to drift between realities the way pollen drifts on air. Time itself could be part of the design. Some children born earlier, some later, a family not only sprawling across existence, but stacked along different temporal axes. If our universe were one such child, then the laws we treat as universal might be legacies rather than absolutes, choices rather than necessities. It is a graceful, unnerving thought, and it sits well with the quiet tone we keep tonight. If you want to float on these currents more often, if this blend of hush and high strangeness helps you unwind, gently tap the current. Like and subscribe to Space Historian so the story can keep running without breaking the calm. The shells, of course, do not confine their mischief to gravity and time. Electromagnetism, the second great thread in the tapestry, snags too. In the vacuum near a gravar, particle-antiparticle pairs pop into and out of existence at a furious rate. This vacuum polarization sows fields that flicker across the entire spectrum, a snowstorm of radio to gamma that can scramble the cleanest signals. A ship crossing such a region would hear its own voice delayed, reversed, twisted. A transmitter would sing one frequency and receive another back, its information smeared into nonsense. Where the shell's geometry focuses, electromagnetic disturbances may spiral into vortices, tornadoes not of air but of field, rolling onward for years at near light speed. They could strip electrons from gas clouds, ionize atmospheres, write auroras across worlds that have never known dawn. Interference patterns in the shell's quantum state could act like cosmic optics, tightening a smear of energy into a beam that travels unscattered for parsecs, a pointer no one is holding. Sometimes the chaos broadens instead of narrows, flaring as a photon storm, a whiteout of light that contains, for an instant, all frequencies at once. Instruments saturate, shadows vanish, and then the sky is ordinary again, as if nothing had happened. Add to this the possibility, long theorized and never seen, of magnetic monopoles birthed in the tumult, solitary norths or souths that warp fields in ways Maxwell's tidy equations were not written to allow. If such particles wander, they could disturb planetary magnetospheres from systems away, tugging at compasses and currents with invisible hands. If there is intention in the shell, it might modulate the storm, lacing it with pattern, encoding, perhaps, messages as old as the object itself in the only medium it fully commands. To us, that would look like noise with a secret grammar, a blizzard in which snowflakes spell. The same disturbances do not respect the delicate coherence of quantum systems. Near a gravar, carefully entangled pairs lose their synchronicity. Superpositions collapse into blunt facts. The fine, shimmering edges of chemistry and biology fray. Picture gravity not as a quiet, steady pull, but as a fever, surging in waves that can be focused, sharpened, and sent like spears. In the warped geometry around a gravar, those waves can be gathered the way glass gathers sunlight, concentrated into narrow beams that do not merely rattle the night, but deliver their entire fury to a pinprick in space. A lens for gravity itself. One focused burst, and an innocent starfield could vanish. Whole systems boiled to mist, memory erased as neatly as chalk washed from a slate. And still, that is the gentle version. Some models whisper about the quantum vacuum, the not quite empty sea from which all things borrow their being, shuddering under a gravar's influence. Regions where particles fizz into and out of existence in pandemics, where space is seeded with brief, strange matter that drifts like sparks from a fire. Those sparks would not be harmless. They would tune the local rulebook, nudging what counts as possible. A subtle vandalism of physics that spreads. But even the most violent wave is a prelude to the real terror, feeding. A single gravar has, in theory, the patience and reach to eat a galaxy. It begins unannounced, gliding into the sweeping arms of a spiral like a shadow that decides to move. There is no hot accretion disk to betray its hunger, no warning flare, no screaming X-ray. The first sign is absence. A bright dot on last year's chart is missing this year. Another and another. The ledger of stars begins to show holes. Bodies fall inward and do not light as they fall. They touch the shell and are swallowed in silence. As it feeds, the shell does not simply gain weight, it becomes a more ruthless net. Every captured star deepens the well, and the well stretches farther. Capture accelerates. Where once single suns were taken one by one, now clusters start to move as if pulled by a common thread. Globulars, swarms of 1 million suns, slide away like beads on a broken strand, processed together by a quantum mechanism that does not glow while it works. For astronomers inside such a galaxy, the sky grows unfamiliar. Constellations go wrong. Beloved alignments slip out of true, then vanish. The maps of children become lies by the time they are adults. Only the gravity tells the tale. Orbits quiver and precess. Invisible mass rewrites the dance. Eventually, the shell grows so wide that it can reach around entire neighborhoods. Not just snaring a star here and a planet there, but swallowing vast swaths of space-time whole, leaving behind hollows where measurements fail. Pockets of geometry with nothing in them to measure. And then it sets its appetite on the central anchor, the supermassive object at a galaxy's heart, Where a black hole roars as it feeds, this other thing hooded in impossible matter drapes its membrane over the giant and rolls it inward like a pearl in cloth. The loss of that anchor is slow ruin. Spiral arms unspool, velocity fields go ragged, and the grand structure drifts toward dissolution while the predator keeps working. From the ground, for any living beings unlucky enough to be thinking during this epoch, it looks like a doom that cannot be bargained with. Systems on the rim go first, the emptying proceeds inward, and an expanding shell of nothing races across the ages. If the thing within the membrane truly thinks, as some dare to suggest, then perhaps it optimizes the feast, choosing heavy regions, dense knots, bright giants. It learns to be efficient. It learns to hurry. The feast leaves ripples. Gravity waves roll outward, braided with the graver's peculiar signature, and in their passage they might seed more of their kind, disturbing neighboring clusters, coaxing new shells into existence the way storms can call other storms into being. The final carcass of a consumed galaxy is a gravar, whose shell spans hundreds of thousands of light years, packed with the mass of billions of stars, balanced in a superposition of quantum states like a coin spinning too fast to name its face. At that scale, even the dark scaffolding between galaxies is fair game. If a gravar can stir the sea of unseen matter, it can drink it. It can grow beyond the boundaries of one island of light and begin to drink the archipelago. And yet, for all its appetite, there is no schedule you can trust, no calendar to warn you. Uncertainty is wired into its bones. The shell's quantum life means it never settles into a single posture. It flickers, trillions upon trillions of tiny reconfigurations every second, sampling a library of possible selves. Imagine trying to predict a coin that never lands. Not heads, not tails, but a whirl that is both and neither, a catalogue of outcomes stacked atop each other. The Gravers field can change in an eye blink, not because matter moved, but because state did. From masquerading as a modest compact object to impersonating the pull of a small galaxy, the metamorphosis could be instant, faster than any warning could cross the space in between. The weirdness runs deeper. The same quantum rules that let electrons tunnel through walls could allow parts of the interior, a place that should be utterly sealed, to seep outward. Bursts of exotic stuff might escape in flashes, outracing light not by speed in the usual sense, but by taking shortcuts through the rulebook. Wormholes could blink into being like sparks, connections between far-apart regions that last an eye flick long enough to tug, to touch, to twist. Through those same caprices, communication in the ordinary meaning of the word fails. An attempt to measure, to pin down the thing's properties, becomes itself a nudge that changes those properties. Curiosity is a small hammer tapping a chaotic gong. Sometimes the shell spews energy, not in the dribbling way a star shines, but as a single appalling breath, outbursts bright enough to shame whole galaxies. There is no warning. Somewhere in the relentless flickering, coherence slips and a storehouse opens. In one heartbeat of space-time, volumes sterilize. Worlds that never knew they were in danger become dust. Then there are the failures so total that our equations do not know what to do with them. Decoherence. The moment when the carefully balanced, many possible shell flattens into something more definite and wrong. A collapse not to a black hole, which we at least sort of understand, but to an object with rules unrecognized. Singularities of a new family perhaps, whose manners towards space and time are alien. Entanglement mocks distance, and the gravar is awash in it. A quantum measurement made on a desk on Earth could, in a fevered version of these theories, become bound to a degree of freedom in a shell across the sky. The desk wobbles a bit in probability. The shell shivers in state. If so, then there is a web here, not metaphorical but physical, linking far separated gravars into a single choir, each throbbing to the other's half-heard tune. Under that singing, reproduction may hide. Bifurcation is the name some give to a peculiar trick. A complex quantum system slips across a threshold and divides, not by tearing apart, but by distributing itself into multiple, mutually coherent copies. A gravar could, given enough stored mass and stress, split its shell into several daughter bubbles, each inheriting the parent's strange talents, each ready to grow. Absorption accelerates. Somewhere, a filament of the cosmic web goes dark as the number of mouths increases. And meetings? Oh, the meetings are worse than the feasts. When two of these bubbles approach, the first clear sign is the bruise they put on space-time together. Gravity waves billow outward with energies that make black hole mergers look like gentle claps. Far instruments would hear that chord from the very edge of what we can see. Closer in, the shells sing to each other. Resonances form, standing patterns that amplify the jitters in both. Before they touch, each is less predictable than it was. Touch may not mean merge. Unlike black holes, which blend into a single horizon, exotic shells can interfere like ripples. Where crest meets crest, the pressure doubles. Where trough meets trough, it halves. The combined membrane might spring them apart at breathtaking speed, two titans rebounding instead of embracing. Or the membranes may interlock and craft a hybrid that holds both lineages at once, an impossible creature whose properties would have been contradictions if you'd asked only one of the parents. Each scenario carries its own firework. A quantum shockwave could ripple from the contact. No ordinary pulse, but a burst of altered law. A packet of space-time that carries with it the parent shell's peculiar physics. It would not merely shake, it would seed. A bubble of different rules could expand at light speed, a frontier where the synonyms of distance and duration break and are replaced. Gravity itself would lose its usual politeness. Near the collision, the field might point in several directions at once, as if up and down both applied and neither did. There are even solutions that replace curves with holes. Not black holes, but literal absences, regions where there is no metric at all, no notion of how far or how long, and into which matter does not fall so much as stop existing as a noun. Entanglement between the two could cinch into a tunnel, a quantum wormhole, linking interiors beyond the touch, leaving the pair forever paired, no matter how far they later drift. New particles might slither out of the vacuum under those conditions, the way unfamiliar notes can appear when you bow a string too hard. The field would be asked to play in registers it does not use for ordinary life. The energy, always the energy, would be enormous. Supernovae, once trusted as the brightest kinds of endings, would be demoted to campfires. There are pathways in the math by which a sudden change in the shell taps the vacuum itself, pulling from the same bottomless account that keeps the universe's fields jittering when no one is looking. One twitch in the membrane, and a sun's lifetime of light is spent in a heartbeat. Those outbursts would not heat things the way sunlight warms skin. They would flip switches, jolting matter across quantum thresholds, making solids blink into fleets of brief particles and back again. Sometimes the outflow is imagined as gravitational lightning, narrow, jagged strokes of curvature that cut with startling neatness. A planet speared that way might separate along a flawless plane, geology diagrammed in an instant by a cosmic scalpel. Worst of all, there is no smoke to smell before the spark. The shell does not rumble with premonition, it just chooses. And the choosing is not even truly a choice, according to those same rules. It is a draw from weighted probability, the universe tossing its coins and allowing an outcome. Some say those bursts can set off vacuum decay, bubbles, where the true ground state of the field replaces the false. Those bubbles do not stop. They expand at light speed and reassign the rules as they pass. Everything is still something afterward, but it is not the same something. Information can be shredded not into pieces, but into wrongness. Every correlation that made a thing itself replaced by chance. If a mind is inside, a mind that understands its shell, then it may learn to aim. Energy can be shaped. Beams can be steered. You might even imagine the gravar using its own violence as a tool. A cosmic artisan with a hammer made of law. And what if the blast leaves behind more gravers than it began with? Quantum reproduction by radiation. Daughter shells called out of ordinary matter. New bubbles accreting around the seeds the burst provides. The sky could be sown with airs. Perhaps this is why the search for dark matter has found so little to hold. If the invisible scaffolding that guides galaxies is not particles flitting through detectors, but compact shells so stealthy they dodge every light we shine, then the census we've taken is a census of mistakes. A graver weighs perfectly and glows not at all. It bends the paths of photons and shapes the flows of gas. It leaves its fingerprints on lensing maps and the motions of dwarfs. It explains the cold behavior, sluggish compared to light, that surveys tell us about. It collects where mass already gathers and keeps away from where mass is rare. It forms the filaments, the knots, the skeleton of the universe. That solace hides a new dread. If dark matter is this, if the halo around our own home is seeded with dormant shells, then we live in a quiet forest filled with predators, sleeping under the leaves. And what sleeps will one day turn. The decay of the fields that hold the shell together might be slow, but slow is not never. As cosmic time wears on, more wake. The acceleration of the universe's expansion could be the sigh of these awakenings, the sum of many small exhalations into the dark. Some of those sleepers could roam near our house. The halo of the Milky Way reaches far past the path of Pluto. A gravar drifting in that deep could be in our ledger already, misfiled as empty space. Entanglement could lace it into a network we cannot sense, a whispering web that knits clusters into conversation, a nervous system for the cosmos, if you like the metaphor, and even if you don't. Time, too, is a victim of these objects. Their gravity is not merely strong, it redlines the dials. Near a gravar, minutes lengthen into years. Years can be stretched into gulfs. Imagine a solar system pinned inside such a gradient. Planets keep to their paths, but the paths take millennia to complete as seen from far away. The star keeps fusing, but the light generated in its core is a slow caravan that needs centuries to reach the surface. These gradients are not uniform. Time can flow at one pace near the fire and another in the snow beyond. Inner planets age quickly, outer planets hardly at all, or the reverse. A clockmaker's nightmare laid over an entire sky, faces all showing true time for where they stand, and none agreeing with their neighbours. To a civilization inside, everything is normal. Birth, learning, art, grief, all take the time they take. To us outside, entire histories would flicker and fade in what looked like a breath. A species rise and fall, a theology's 1,000-year argument, a telescope aimed and remade across ages, snapshots compressed to a blink. Where gradients sharpen, stranger things can happen. Pathways through the geometry can loop back on themselves into closed time-like curves. An object placed on such a path can return to where and when it started, not by cheating across a shortcut, but by faithfully following the route the metric lays out. Effects can walk in front of causes there. Paradox ceases to be a puzzle and becomes a property. The distortions do not need to stay local. Gravity waves from a restless shell can carry time's slowness outward, swathing distant systems in delays that have no visible source. In principle, it is a shelter, a way to wait out a hostile universe. An old species might retreat into a zone where the outside ages quickly while they drowse and wake to a future they did not have to live through. In practice, it is a trap. Once drawn too deep into the slow, the rest of the universe races away. You go on, but you never catch up. If there is a mind inside, its clock could be a glacier's. It could juggle patterns across epochs, make decisions measured against mountains' lifetimes. From our viewpoint, it would be paralyzed. From its own, it would be graceful and fast. Time shadows can form, places cut off from the shared flow altogether. Not running forward, not running back, suspended. Matter there is neither aging nor changing. It is stored, an archive or a oubliette. Multiple gravas complicate the clock beyond all mercy. Their wave fields interfere, not just in space but in time, knitting mazes of faster and slower lanes, sideways flows and cul-de-sacs. Whole galaxies could find themselves inside those mazes, wandering through eras that do not agree. We may already be watching the aftermath without knowing it. Dark companions tug stars in ways that suggest black holes, but refuse to glow even when they should. Sagittarius. A*, the heavy heart of our own galaxy, sometimes behaves like an eater that forgets to shine, drawing in material without the usual screams of light, as if a shell were drinking instead of a horizon. Our new ears for gravity hear rings that do not match black hole songs, notes more consistent with a membrane than with an event horizon. Stars occasionally wink off the ledger without exploding, as if touched by an invisible prison wall. Lensing maps of dark matter squirm too quickly, as if the lenses themselves were changing shape in real time. Some millisecond bursts on the radio sky crackle with the signature of quantum instability rather than of magnetars or mergers. In the afterglow of the Big Bang, there are fingerprints that look like objects which swallowed without shining. Even the mathematics flinches. Try to write down a stable solution and your series refuse to converge. Ask Einstein's elegant field equations to include a shell with negative energy density, and the answers you get back insult causality. Terms appear with imaginary masses and ghost fields, horrors that mathematicians know how to handle on paper, but that physicists dread in the world. Stability maps look like trapdoors. Tiny nudges flip systems from one kind of balance to another with no warning at all. Interiors that close upon themselves in time are not exotic exceptions. They are the standard. Gravity becomes complex, literally with real and imaginary parts, hinting that the force we thought we knew is only a shadow of a higher dimensional dance. Matrices with infinitely many rows and columns are needed just to hold the state, and even those are not enough to solve for it. Speed of light is a variable. Self-referential structures that behave like equations, aware of their own solutions. It all reads like a fever dream scrawled across a chalkboard. On these same boards, though, another story is penciled in the margins. Birth, bubble nucleation, eternal inflation in miniature. Inside a shell, conditions may be so extreme that the vacuum trips from false to true in patches, each patch a new universe in embryo. The shell's negative pressure is then more than a curiosity. It is a womb wall. The membrane keeps newborn physics from colliding with ours. It lets many realities nest in the same place, separated not by distance but by rule. What if the mind inside can choose which bubbles to spark? What if it can tweak constants, try combinations, run experiments measured in universes? Each absorbed star a grant of energy, each grant spent in genesis. Offspring expanding faster than light, punching their own time into being, some barren and short, some gentle to complexity, some connected back to the parent by threads of entanglement so that information moves between them like scent on a current. Perhaps even our world began as one such experiment, a bubble lifted like a lantern by a parent we cannot see. Birth leaves noise. Electromagnetic weather spreads with the shells. Vacuum polarization that fries radios, jumbles frequencies, reverses polarizations, or scrambles the message into glossolalia, dead zones that last ages. Tornadoes of field, long-lived, near light speed, combing electrons from atoms and ionizing whole atmospheres. Interference fringes that focus energy into needle-thin beams across interstellar distances. Photon storms that are not single colors but all colors at once, from radio to gamma in a single white roar. Magnetic monopoles march through the equations. If the shell births them, they make compasses go feral and planetary fields misbehave. Think of gravity not as a steady hand, but as a set of strings a mind could pluck. Around a Gravastar's skin, thin as a rumour, dense as a city of suns, those strings tighten until they sing at pitches millions of times harsher than anything near a black hole. Time, under that strain, slackens into near stillness. Whole star systems fall into temporal tar. Planets keep tracing their lanes, but what used to be a year becomes a millennium when watched from afar. The parent star keeps fusing in its heart, yet a single photon trudges upward for centuries before fumbling free. These distortions are not tidy. They grade and ripple, laying time in uneven sheets across an entire solar system. An inner world might crawl at one pace while a distant ice giant flickers along much faster or slower, like a clock wall in a station where every face tells a different hour. If minds survive inside such a region, their histories would race like candle flames in a draft. 10,000 years of art and science blinking past in the span of a distant onlooker's sigh. The shell's quantum peculiarity doesn't stop at slowing. It can kink the direction of time itself, producing pockets where effects arrive before causes, or eddies where moments loop back into themselves. Physicists give these loops a name: closed time-like curves, a sterile phrase for something that could let a probe meet its own launch. Follow one such path, and you would not merely retrace your steps, you would overtake them, pass yourself, and return to a past that remembers you. These temporal distortions don't need the Gravastar to be close. Waves of curvature, born from fluctuations in the shell, sprint outward at light speed, carrying with them a kind of temporal drag. A remote civilization might find its days lengthening with no culprit in sight, just the silent wash of an unseen visitor's wake. In the gentler stories, someone learns to use this, not flee it. A species staring down catastrophe might dive into a Gravastar's slow time halo, like sailors into a calm bay, sleeping through eons of chaos while the wider universe ages outside. They would re-emerge blinking into a sky that has drifted by billions of years, stepping out of their bunker to find the stars rearranged and the dangers gone, or replaced by new ones no one had imagined. But the same trap that preserves also imprisons. Cross the boundary and the outside universe runs away from you. If your sunlit system sinks too deep into the Gravastar's tide, from outside it will look frozen, a snow globe set on a shelf. Inside, mornings still arrive, children still grow, empires still rise and fall. From beyond, nothing much seems to happen at all. Meanwhile, if there truly is a mind within that shell, something with patience measured in geological eras, it would think at rates that make our supercomputers feel like sundials. It could consider strategies across epochs, change plans across ages, and never be hurried by the light of any star. It would grasp time as we grasp breath. The distortions throw long shadows, temporal hollows, where the flow of moments detaches from the wider stream. Inside such a shadow, matter and energy can linger in a suspended poise, not advancing into tomorrow, not wholly anchored to yesterday. Imagine an archive stored in the pause between heartbeats, a museum of realities that refuse to tick, and multiple gravastars complicate this landscape beyond simple dread. Their waves can add and cancel, creating interference not in water or air, but in the river of time itself. The result is a maze of gradients, crossings, and cul-de-sacs, where minutes slide one way over here and sidle sideways over there. Navigate badly, and a planet or a galaxy could wander into a trap with no path back to the common now. If such monsters exist, traces may already be written into our observations, like fingerprints in frost. In the Milky Way, some companions tug stars along in ellipses and whirls, mass enough to rule those orbits but dark to every band of light. They do not flare in X-rays. They do not grow hot. They simply move their neighbours and keep their counsel. One of those could be a gravastar wearing a black hole silhouette. At the galactic centre, Sagittarius A** sits like a quiet judge, 4 million suns in a space smaller than an orbit. It sometimes behaves with a weird reserve. Matter seems to vanish into it without giving the usual show. No luminous frenzy, no roaring disk, which has tempted a few minds to whisper, perhaps not an event horizon after all, but something stranger hiding in the same geometry. Our new ears, gravitational wave interferometers, have caught songs that don't quite fit the hymnal of black hole mergers. Some ring like a struck bell, but with overtones that hint at a stiff, reflective surface rather than a pure horizon. Exotic shells sing different notes. Perhaps we have heard a few, faintly, beneath the noise. Then there are the disappearances. Stars that winked out without the mercy of a supernova's farewell. No shock, no plume, just absence and a gravity bill unpaid. A gravastar would devour in silence. It would leave nothing but altered orbits and questions. Dark matter itself, that invisible scaffolding holding galaxies in their graceful whirl, might be a population of sleeping gravastars or their offspring. The clumps and filaments we map by lensing shift and breathe in ways that a gas of simple particles struggles to explain. If some of that mass can change its signature, switch modes, or deliquesce into other states, the map grows easier to read, and far more frightening. In colliding clusters, the dark component sometimes glides through like ghosts. A shell that lives partly out of our dimensions would do exactly that. Fast radio bursts, millisecond screams brighter than a day of sunshine, arrive with energy budgets that strain our diagrams. Some patterns match what theorists say a twitching exotic shell might cough into the cosmos during an instability, a needle jabbed into the vacuum that sparks the entire spectrum. The afterglow of the Big Bang, the cosmic microwave background, hides delicate freckles, subtle features a few teams argue could be fossils of primordial exotica that fed without shining. Binary systems with jittery orbits hint at invisible partners whose pull changes on timescales that ought to be sedate. If a companion's gravity moves as its shell hops quantum states, the wobble would look like that, a metronome with a faltering hand. Even the acceleration of the universe's expansion, our dark energy, could be a symptom of gravastar activity slowly rising across cosmic time. bleeding exotic pressure into the void, and there are gamma-ray bursts, some so ruthlessly efficient that matter seems to become energy with textbook perfection. Ordinary engines, fusion, accretion, always leak. A quantum instability in a shell need not. Pulsars, those clockwork dead stars, occasionally stumble in their ticks. Some of those stumbles could be the caress of something we can't see, the brush of a field that isn't quite gravity as we know it. All of which is a long way of saying the sky contains a handful of puzzles that fit the shape of a gravastar better than they fit anything else. But the real terror lies not merely in the phenomena, but in the mathematics that insist on them. Einstein's field equations describe how matter tells space-time how to bend, and space-time tells matter how to move. Feed them a shell with negative energy density, a substance that pushes rather than pulls, and the equations start offering answers with teeth. Causality threatens to tangle. Energy bookkeeping looks like it's missing pages. Some terms require masses that act like the square root of -1. Imaginary mass. Mathematicians are unbothered by imaginary numbers. Engineers use them to keep planes aloft and phones in tune. But a mass with that property is a different kind of chill. It suggests an anchor that extends into dimensions our senses can't stride. The series you sum to quantify the shell sometimes refuse to converge, sprawling toward infinity as if certain properties of these objects will not be coaxed down to a tidy figure. Quantum fields, when drafted to the job, insist on solutions that live in more rooms than we have keys for, 11 dimensions or more, spreading the shell's identity across spaces we cannot enter. Catastrophe theory puts a label on the behavior. Systems that switch from quiet to crisis without warning, like a hillside that slumps all at once after years of silent creep. Inside, the same equations grow more mischievous. Closed time-like curves are not a rumour there. They pop out of honest work on the metric. Paths loop. Events fold. Gravity itself can take on complex values in some formal solutions, sporting both real and imaginary parts the way a wave has magnitude and phase. Ghost fields, entities with negative energy and momentum, appear in the algebra like necessary evils, crucial to hold the shell steady, sacrilegious to our current physics. To form a gravastar, you are forced to admit quantum gravity terms, the marriage of relativity, and the quantum that we do not yet fully know how to write. Matrices that ought to be finite grow infinite legs. The space of states mushrooms beyond calculation. Even light, the cosmos's speed limit, becomes a local variable in certain models inside the bubble. It is not a law broken so much as a law rewritten for another jurisdiction. Some of the mathematical structures that arise look unsettlingly self-referential, as if parts of the description are computing properties about themselves. It tempts one to poetic nonsense about equations that think. Still, the flavour lingers. If the shell is a processor and the interior a data sea, the line between description and described grows thin. At those same edges, something like creation sneaks in. Quantum tunneling lets regions of altered vacuum pop into being. Bubble nucleation gives you swatches of space-time with new settings. The shell, with its negative pressure, can be the threshold where such bubbles sprout. Each could bloom into a universe with its own constants, its own chemistry of possibility. Eternal inflation then becomes not a cosmic once upon a time, but a method. A garden that never stops seeding. A single gravastar could be a nursery, a forest of them, a continent of worlds. If a will lives within, it could guide the sprouting, choose parameters, mothers and fathers for the baby physics. The newborn universes might remain entangled with their parent, swapping whispers of information across forever. and perhaps absorption of stars and planets in our universe is not mere feeding. It's the raw material for their births elsewhere, the genetic code for realities we cannot find. All of that would be noisy, electromagnetically noisy. The shell's fluctuations polarize the vacuum, flicking particles into and out of existence like fireflies that never land. That flicker breeds a murmur across the spectrum, radio to gamma, a blizzard of static that garbles messages and chews through circuitry. Within those regions, signals emerge bent and battered, frequencies shifted, polarizations flipped, payloads scrambled. Dead zones bloom where technology fails, like a heartbeat that forgets to beat. Rotating vortices of field, electromagnetic tornadoes, can spool up and drift for years at near-light speeds, sanding electrons off atoms across entire systems, thinning atmospheres and shocking magnetospheres into disarray. Interference patterns in the shell's quantum fabric can focus energy into thin, clean beams, cosmic pointers drawing lines from impossible distances. Photon storms flash with every frequency at once, a white fire that is not heat so much as a universal reset. Magnetic monopoles, if the shell births them, don't play nicely with our neat Maxwell equations. A single one could rewrite local magnetism, a flood could retool an entire region. Solitary self-sustaining wave packets, electromagnetic solitons, could carry chaos for 1,000,000 light-years without tiring. And in the deepest weirdness, signals might wander back along loops of time, arriving before their senders have pressed the key. If such a visitor ever slid into our own system, it would be the subtlest invasion imaginable and the most devastating. The planets would feel it together, as if the sun had developed a second gravity overnight. Orbits would stretch, tilt, topple into eccentricities that broil and freeze. Earth, jerked into a long ellipse, would bake under close passes and shiver at aphelion. Plates would crack, mantle would roll, volcanoes would talk, our magnetic shield would falter, then fail. The solar wind would strip the sky like paint. Cosmic rays would peck at DNA, at circuits, at the fragile dance of chemistry that keeps neurons true. Quantum meddling would leak into our materials, bonds slackening, recross-linking, rare nuclei born where no forge should be. The shell's gravitational waves would knead the crust until continents tore like pastry. Travel would lose meaning. To go to Mars might cost a handful of hours for the crew in a zone of slowed time while months bleed away on Earth. Send a message and it would arrive out of sequence. Plan, and your plan would be about the wrong now. If a consciousness in the shell counted us as a single morsel, it could widen its membrane to swallow more than one world at once, sweep Earth, Mars, the belts, into its interior and keep them like flies trapped in amber. The sun would not be spared. Its fusion could be quenched or goaded, a sullen coal or a detonation. Either is an ending. No satellites, no grids, no radio, no net. In hours, we would be a quiet species under a loud sky. Wormholes, brief and biting, might thread our space to others, bringing in matter and rules that do not match ours. Survive the first week, and the next 1,000,000 years still look poor. The shell's background rumbles, seeding the void with waves and fields that make a long home impossible. Where such a thing passes, it leaves cemeteries. Systems crumble into grotesque arrangements, worlds with cores missing, stars that burn but never shine, encased in cloaks of strange stuff that traps their light. The alchemy of entire planets changes. New isotopes with baleful half-lives haunt the rock. Gravity itself remains kinked, space-time scarred, so that orbits trace paths the textbooks declare illegal. Regions of absolute technological silence remain, an electromagnetic hush that refuses engines and radios alike. In the rubble, there may be fossils unlike any other, not bones but patterns, a civilization's quantum state etched into knots of exotic matter, a museum with no doors. Time echoes linger, loops where a nova recurs without end, where a comet falls forever and never quite hits. Residual exotic matter makes gravity misbehave for ages. It is a trap for explorers, a net for returning cultures. Around some stars we see enormous constructs, ribbons of shadow, arcs of mirror, that look like attempts to move worlds. Grand gestures, and often too late. In other places lie information shadows, volumes where the quantum correlations that make matter itself coherent have been shredded and cannot be rewoven. Not emptiness, but an absence more thorough than vacuum. Planets kicked free drift as orphans through the dark, carrying in their frozen rains the chemistry of vanished seas and the pollen of dead gardens. And scattered among these wrecks are clues, shards of a bigger story, pointing back to the first minutes after our cosmos blinked awake. For the Gravastar story rhymes with the inflation story. Negative pressure, runaway expansion, the right kind of field rolling on the right kind of hill. These are the same tools both tales use. It may be that Gravastars are relics of that ancient physics, fossils of expansion engines that never quite wound down. Or bolder still, we live inside one, a bubble birthed by a parent shell in a parent world, our constants chosen by a mind that wanted company. The patterns in the microwave afterglow, the CMB's faint mottling, bear features some say align with early Gravastar mischief. The flatness problem, the horizon riddle, these famous headaches grow less painful if shells and inflation are aspects of the same anatomy. Dark energy might seep from interiors into our space, acting as the persistent lever that pries galaxies apart. Even the spark of the Big Bang might have been a collision elsewhere, two shells kissing in a higher room, their shock birthing our stage. Entanglement between primordial shells could explain far-flung synchrony, why patches of sky that were never neighbours still share temperature secrets. Perhaps the blueprint for how atoms bind and galaxies spin was printed on a boundary by an older world, then pressed into ours. Zoom back down from that dizzy height and the particle zoo opens its gates. In the wake of a shell, strange species may be born. Vacuum polarization becomes a seedbed. Particles with charges we do not allow in the standard model stroll through. Magnetic monopoles that force our old equations to grow new terms. Tachyonic disturbances that model time as a two-way street. Axion-like whispers that slip through rock as if it were fog. Sterile neutrinos wander entirely by gravity, indifferent to the rest of the forces. Ghost particles where negative mass, falling up. Strings from higher dimensions pierce our space as points, tugging information through unseen corridors. Supersymmetric partners might wink into being where our three-dimensional world brushes a neighbour's. Chameleon fields could change their faces with density, invisible here, truculent there. A mind in the shell, if it exists, could use these as tools, change the local rulebook, rehearse with different versions of physics, turn regions into laboratories or gardens. Some particles might breed, a single spark seeding an avalanche, a contagion of altered constants rolling outward. Others might straddle worlds, acting as bridges through which energy and meaning pass between parallel halls. This becomes a story about gravity itself. Perhaps our beloved theory is only a chord in a larger song. The shell's fields tease out paradoxes, repulsion where we crave attraction, superposed gravities that refuse to be one thing or another. Quantization of the field would mean gravity comes in notes, not a glide. Holography whispers that the shape of a region is coded on its edge, as if the universe prefers to write on surfaces. Entanglement might lace gravity across distances instantly in ways we do not yet sanction. In the sharpest speculations, intention enters, a universe where consciousness and curvature are not strangers, but partners, where a will could nudge a metric, where the waves we detect carry not only energy, but diagrams, maps of the lattice beneath continuity, hinting that space-time is built from discrete units, snap-fit bricks that can be rearranged.